see a quadratic and you see some sort of direction, like even ignoring that, what's the first thing most people think that they're supposed to do? Factor it, right? So let's just look and see. Factoring, now hold on. Technically, we have talked about factoring this year in context of zeros, right? What are zeros again? What kind of intercepts? They're x values when y equals 0, right? So they're x values when y equals 0, the x-intercepts. You guys know the modified x method, we'd have to do a times c. Is that bad? Can we factor nicely factors of 14 that add to b4? What's the only other way that we'd be able to... Oh. X equals negative b plus or minus square root b squared minus 4ac. All over 2a. No. But that would be finding the zeros. So to find the zeros, we would do, to find the zeros, different problem, but to find the zeros. X equals negative b, that didn't work, and there's a square. Hold on. My computer's been possessed all morning. Not literally. Negative b plus or minus square root b squared minus. Why are you judging so much right now? Okay, so is this good or bad?
Bad.
Why is it bad? Ignore the little baby square on the board. What's 16 minus 56? Imaginary, can't do it. It's true about the zeros. There are none. There are no x-intercepts. How can a parabola not go through the x-axis? Oh. Oh, yeah, if it shifted away, then it might not have any zeros. Okay, well, that's for zeros. But what was the objective of this problem? Complete the square. Complete the square says you want to get this into a form of... Ooh. Look at the backboard. Standard form. Have we talked this year about how h and k are sometimes really important in different shapes? Yeah. What shape were we talking about when we talked about h and k? A circle, and hk was the center. Midpoint was like of a line. So hk was the center. But wait, we're not dealing with circles anymore. What are we dealing with? And how do I know it's a concave up like a cup parabola? Because the a is positive. What's the one important point of a parabola? It's not a center. If we can get it here, even though this guy doesn't have any zeros to help me kind of figure out where his vertex is, he still has a vertex. Every parabola does. And he doesn't just have any vertex, he has a vertex that we could technically call a minimum. And in certain application-y problems, like when you're dealing with finances, sometimes it's nice to be able to minimize the cost and maximize the profit. And that's just one example of mins and maxes and how they're important. But coming back. So if the vertex is so important, and completing the square is one way to find the vertex, and it's the only, not quite only, but the main way to get standard form, what's the difference between this and what we tried over here? Yeah, when we were finding the intercepts, we were just trying to look for, if you guys remember, we were just trying to like get this as a product of linear pairs. We were just trying to say something like it's 2x plus and x minus, but this doesn't look like that. This just says, give me some factors. I don't care if they match or not. This says, no, I need a perfect square. Complete the square. Points to this right here. Trying to take any quadratic and see that it could be involving a perfect square with maybe some extra stuff going on. Now, is this a perfect square right now as it is? No, it's really bad as it is. Can't even factor it. Try quadratic formula to find the zeros and still, Okay, so let me switch my colors. Does anybody remember something to do with getting a leading coefficient of 1? But what's the problem if I start pulling out a 2? Okay, okay. Don't worry. I'm allowed to have somebody on the outside. Don't worry, I'm allowed to have somebody on the outside. Why'd I leave this big old blank? Because I'm about to fill it. I have to complete, because as it is written is not good enough to get it here. We already took as it is written and it wasn't working out so hot. No perfect square. But if I just take the x terms, if I pull out the 2, if I move the 7 off to the side, you okay? Hang in there, just kind of wiggles a little bit. The question is, how do you complete the square? Complete what? The blank. To do what? To get a square. Oh, complete the square. But with what? Well, that's part of the process that we need to review, of taking the middle term, cutting him in half, and then squaring him. 2 cut in half is just, and 1 squared is. And every time you complete the square, which you fill in that blank, why did I do minus 2 times? If I just did plus? You guys have taken chemistry, haven't you? Isn't it super important to keep the equations balanced? So can I just randomly go like, oh, I'm going to add something? I have to add and subtract somewhere else, or else it's not balanced. So if I add a 1 here to make it nice for my square, I can't just add 1, which is really 2. I need to also offset it so that I'm adding and subtracting somewhere else and I'm still balanced. Now what does this do? Well, now I can go and say, oh, hey, guess what? This guy, he's really x plus 1 quantity squared, and 7 minus 2. Well, that's going to be 5. This and that are the exact same thing. How can I prove it to you? How could I prove it to you? How could you prove to me that these are the same thing? What could you do? I guess you could plug in x equals 1 and x equals 1 and see if the y's match. I heard someone say solve. What did they mean? I guess you could set equal to 0 if you wanted, or simplify. That's what I was thinking. Couldn't we theoretically FOIL this guy? So couldn't we go ahead and say, all right, is this correct? Let's not kill puppies. Some of you and the puppies and the seals. Keep working. Don't give up on these, okay? You would have your test back. We have one person that still needs to make it up. If you want to come see it quickly after school, you can drop by. The grades are on RedWeb, right, as of last night? I think so. You'll get them back in a day or 2. Pause. What did I mean by don't kill puppies? You have to FOIL it out. How do we FOIL? First, outer, inner, last. First, outer, inner. Oops, too many pluses going on. Yeah? Don't kill a seal. What was chilling outside of everybody? We FOILed right. There's a smiley face. Plus 5. Plus? Plus 2 plus 5? Was I right? Okay. That's completing the square. This was us making sure we did it right. So once we complete the square, once we complete to make the square, we're able to say, oh, hey, I know his vertex. His vertex is whoever's in the H spot. So who is this guy's vertex? Careful. X minus H. So it'd be a minus a negative 1. And who's the K? Yeah. I know his vertex. And if you guys want to see something really trippy, if this guy had zeros, instead of setting this equal to 0 and having to worry about the modified x that didn't work and then having to remember x equals negative b plus or minus square root b squared minus 4ac, you could just complete the square and set y equal to 0. See what happens. How would you solve for x? Not yet, not yet. Subtract the 5. Then divide by 2. Is it okay if I write -5/2? Then, and since I have square root of a square, that's plus or minus. Now, what's still the problem? Still none, which we already knew from the quadratic formula, but guess what? If it had worked, this and that would be the exact same, and the quadratic formula never had to actually be used. Guess what? Quadratic formula is an American cheater shortcut for people that are too lazy to complete the square. In other countries, they don't learn something like this. When they come to America, they're like, what's that? They just do this every time, and they never have to worry about memorizing that. Joe? I said some people, but Joe, back in the day, maybe you guys now learn it. Oh, you heard high schoolers. So maybe the people that have come middle school hadn't seen it before. But I didn't remember if it was just Chinese students, but I have had students from like Vietnam and from Korea and a few different ones that would only complete the square, and when I tried to show them this, they were like, I don't know. So maybe they learned this one later as a shortcut. But I will say, other schools, other countries teach foundational math a lot better because they force you to do it the hard way first. Anyway, interesting. Long story short, quadratic formula is really complete the square. Complete the square is really important, and we need to relearn it. So let's go to section 2.1. Some of you guys were like, I think I've seen that before, and some of you are still like, I have no idea. So we need to take some notes. But before we take some notes really quickly, what's this page? It's not even quadratics. What's this whole page about? Why? What's the title of chapter 2? Chapter 2, polynomials. We're just starting with quadratics. We've talked about lines a lot. We've talked about quadratics. When did we talk about quadratics? Section 1.6. Go look really quickly. Even in the table of contents. What was section 1.6? Parent functions. Remember how we talked about square root of x, absolute value of x, x squared, y equals x, the constant function? Were we trying to master any one of those, or were we just getting a general idea before the transformations in 1.7? Yeah, general idea. So now it's time to master quadratics. But before we do, for the entire chapter, introduction, polynomials. Guess what? Nth degree polynomials denote there being a term of x to the nth power, the highest power, and you can have n plus 1 terms altogether. So, how many terms can a line have?
2.
Yeah, it can have an mx and it can have a b. Does it always have an mx and a b? No, not always. But it has up to that. How about a quadratic? How many terms can a quadratic have? 3. Does it have to have all 3? No, but to be a quadratic, what one term must it have? The x squared term. But it might also have an x term, and it might also have a number, a constant term. Good. How many terms can a cubic have?
4.
Because it can have an x cubed, x squared, x term, and a constant term. But what's the only one that must be there? Got it. So this whole definition is saying for any nth degree polynomial, for any nth degree polynomial, whenever you hear me say that, I'm just talking about, is it a cubic with a degree of 3? Is it a quadratic with a degree of 2? Is it a quartic with a degree of 4? An nth degree polynomial, this whole formula is saying basically it can have n plus 1, and I should change this. It will have up to n plus 1 terms. Cubic can have up to 4, quadratic can have up to 3, a linear can have up to 2. It can have up to n plus 1 terms. And I can't define a polynomial without keeping it general, because who knows what that degree is? It can be anything. But n is the highest power of x. And have you guys ever heard like pastors or teachers ever use like to the nth degree? Maybe not, but it's a thing. To the nth degree. They're trying to talk about, hey, like, oh, it's super, super high or super, super fast. And they can be talking about, like, it might not totally be known, but to the nth degree. Anyway, this is how nth degree at least applies to polynomials. Literally, what degree? I don't know, depends on the problem that you're given. But in this whole section, what do all quadratics have a degree of? 2. Squared, so therefore the degree is 2. So let's talk about some general stuff with quadratics quick. Every quadratic will have a degree of 2. Every quadratic will have a degree of 2. If I was to go into the technical definition of a quadratic, I would have to bring in things like foci and directrices. Yeah, we're not going to do that until later. That's a much more technical definition of a quadratic. For right now, we're just going to keep it. Oh, I don't know, because it's a big old typo that I need to go fix in a second, huh? We'll keep the definition, the basic form that you guys have seen for a long, long time. We'll just keep it with the basic form that you guys have seen for a long, long time. Thanks, Lauren, for seeing that. Without going into foci and directrices and all this weird stuff, which is important for parabolic reflectors and all this kinds of different applications. We'll just keep it with the normal, y equals ax squared plus bx plus c. But here's the problem. That is not going to be, for this entire section, our standard form. Our standard form is going to be the one that you just saw me find. A times the quantity x minus h quantity squared plus k. The basic form that you've seen for a long, long time isn't going to cut it. It's okay. It's good. With a quadratic formula, I guess you can find the zeros if they exist. I had to make that little quick disclaimer, right? Because of what we just saw. This form isn't awful. It's a standard form, and if I were you, I might highlight that because you're going to see that word in homework. What they're talking about is this one. Y equals a times the quantity x minus h plus k, where hk is your, what did we already say? Vertex. There's more to this page. I just don't remember what. Oh, yeah. There's a little, oh, hey, with this form, by the way, it's not enough just to factor this with linear pairs. They might match, they might not. We have to get it to be a perfect square, hence complete the square. So here's where we're going to take a timeout and write down directions of how to complete the square. But first of all, make sure that you write down, in order to get the standard form, we have to complete the square. Because the modified x of this guy, trying to do our AC and trying to do our B, trying to figure out our little factors in order to be able to group and then get linear pairs, doesn't always necessarily get us here to the perfect square. But this process always will. So what was good for the basic is not good for the standard. So let's go ahead and take a second and review completing the square. Nice thing is you guys just saw me do it. And so now we're just going to write out the steps. Let me turn off the light. You don't need to skip any more lines besides what's already shown. Like the little asterisk is saying, like, hey, skip a line, there's more coming. But here's where some of that wording that I was using, getting a leading coefficient of 1, forming your perfect square. As you guys write that, I'm going to show a little bit of Algebra 1 review over here, but keep writing. Ugh, I don't like that marker. Up here on the board, if/when you guys finish writing, I've written a perfect square. A perfect square spell. There are two different ways of looking at a perfect square. One way is looking at the factors and saying, oh, hey, it's a binomial squared. So this would be a binomial squared. Or you could look at a trinomial and say that it's a perfect square trinomial, meaning that it factors this perfect square, or this binomial squared. In Algebra 1, if I taught you Algebra 1, I tried not to have you memorize this shortcut just because it causes you to kill puppies later on in life. So I tried to have you FOIL it every time and just say, whatever, it'll always be right if you think of rewriting it and FOILing it out. However, there is a shortcut that says if I'm trying to factor, I can either take half of this middle 2a, or I can take the square root of this a squared to get back to my perfect square, my binomial square. And that's where this whole little inside comes with forming a perfect square. Now, first of all, to get a leading coefficient of 1, you have to factor out a, which is going to look like a times x squared plus b over a x plus c. That's the first step. Factor out a. Now, sometimes a is a 1, so it doesn't matter. It doesn't really change anything. But if a is not a 1, we factor out an a away from the x squared, away from the bx, which means we divide, and the little c we just move off to the side. And in doing so, we've left ourselves a blank. For those of you that like formulas, you can actually always set it up just like this. You're going to do a plus blank on the inside and then a minus. If you did pull an a out that's not 1, a times, then you could have another blank. That's not going to be good. Can I move you guys? There we go. But the dilemma is we need to add in something to the blank. And so adding in something to the blank, it's always going to be 1/2 of whatever the middle term is now. Which, some of you guys might remember, h equals negative b over 2a is actually a little shortcut to getting to just the h part. It is a little shortcut that you could use way back here at the very beginning with ax squared plus bx plus c. But you have to take that middle term, cut it in half, and that's where it gets a little tricky because then you have to square it in order to add into this term right here. And maybe some of you can kind of see why. We have to take what was there, we have to cut it in half and then square it, cut it in half to get to a and then square it to write our a squared. And as long as we have done that properly, then we can go ahead and simplify into this little formula down here. Now guys, you saw one done today. Guess what you're going to have to do tomorrow? Do it yourselves and have to remember each of the steps. But don't worry, I'll be here to help you along the way. This homework's not due until Wednesday. Bye guys. But some of you might want to watch some videos tonight being like, complete the square. Ugh, I need to remember it. Later, Gators.